In this video I want to talk about the examples and common properties of acids and bases. So as you see here, acids and bases can be in terms of solid, liquid, and gases. For acid we can have a solid, we can have acetyl salicylic acid, and base can be sodium hydroxide or NaOH, liquid acetic acid. And from the base side we have aniline. Gas is going to be hydrogen chloride, and base is going to be ammonia. So let's see what are the properties of acids and bases. In terms of taste, acids taste sour, bases taste bitter. So that's the difference, sour versus bitter. And be very careful, do not taste any chemical in the lab. In terms of texture of solution, acids do not have a characteristic texture, but bases feel slippery. Never deliberately touch chemicals. Strong concentrated acids and bases will burn your skin. They are corrosive. In terms of reaction with phenolphthalein, acidic solutions, in phenolphthalein, when you add phenolphthalein in acidic solution, it's going to be colorless. In basic part, we have a pink solution. So when we have a basic solution, when we add phenolphthalein to it, this can be pink. When we have acidic solution, it is colorless. Reaction with litmus paper, acids turn blue litmus into red, and bases turn red litmus to blue. B and B, base is blue, acids and red, D and D. Next one is reaction with metals. Acids react with metals above hydrogen in the activity series to displace hydrogen. Bases react with certain metals such as aluminium to form hydrogen atoms. Reaction with carbonates, carbon dioxide is formed when we have reaction with acids. For bases, no reaction occurs. Reaction with ammonium chloride, which is NH4Cl, there is no reaction with acids, but with bases, ammonia, NH3, a gas with a characteristic odor, is produced. Neutralization reaction, acids neutralize basic solutions, and bases neutralize acid solutions. Reaction with fatty acids, no reaction occurs, and bases react to form soap, and it is called saponification reaction. Aqueous property of oxides, non-metal oxides form acidic solutions. For example, CO2 plus H2O is going to make it carbonic acid, H2CO3. Metal oxides form basic solution. For example, CaO plus water is going to be CaOH2. Amount of dissociation in aqueous solution, in terms of strength, it means strong acids dissociate completely, weak acids dissociate only partially. Strong bases dissociate completely, weak bases dissociate only partially.